Here again, more computing with scientific notation. Last video we did was on addition, adding numbers in scientific notation. It's getting late, but let's do a subtraction problem. So let me adjust this slightly. So here we go. So let's subtract 6 7/800 times 10 to the fourth minus 4.13 times 10 to the second. That is a 10. It may not appear to be, but that is 10 to the second. I'm not going to go into quite the detail in subtraction that I did with addition about exactly about the factoring, but we're going to approach this just like we did addition, and we're going to factor out a 10 with an exponent that we can match them. Right now, 10 to the fourth is not the same as 10 to the second, but we can certainly rewrite this, specifically the 10 to the fourth, as follows. So I can write this as 6.78 times 10 to the second times 10 to the second. Once again, same base, add the exponents. So we kind of did this in reverse. That is, we took the 4 and we broke it up. And that's going to be minus 4.13 times 10 to the second. And now I notice I have 1 10 to the second here, and I have at least 1 here. Recall that when you factor, it has to appear the same amount of times in each piece, because the subtraction sign really does change the problem quite a bit. So what I'm going to do is I'm going to factor out this 10 squared out of both of these. Here's my 10 squared, and then I've left 6.78 times 10 squared minus 4.13. And all of that, remember, is being multiplied by 10 to the second power. I hope because there's a space here it doesn't confuse. I'll put a times in there. It's next to it. So let's combine this right here. If I was to multiply 6 7/800 times 10 to the second, that's moving the decimal point over twice. And so this whole thing here becomes 678 minus 4 1300. Remember, this is inside the parentheses because we're doing order of operations. Now I'm going to take care of what's inside the parentheses. Times 10 to the second power. I just copied this part down. Not even done anything, I just copied it. But now I am working inside the parentheses, right? Because I got to do that before I do any multiplying. So let's do this subtraction over here. So 678 minus 4.13. I made sure I lined up my 1. So here's my 1s. I'm lining up. So I have a decimal 0, 0. I could fill these in, and let's do the subtraction. Looks like I have to borrow in order to be able to take, because I can't take 3 away from 0. So I'll borrow a 1 here, and I'll put over the tenths. I'm going to have to borrow from the 10 there, from that, in order to make this 10. So I have 10 in this place value minus 3, 7. In the tenths position here, right, because I'm still to the right of the decimal, I have 9 minus 1, that's 8. The decimal point comes straight down. Now I have 7 minus 4 is 3. It looks like the other two parts just come straight down. So inside my parenthesis, I have this value right here, 673.87, and that's being multiplied by 10 to the second power, right? That just gets copied down. Okay, well, this is not scientific notation, so I need to rewrite this. If I move this over twice, remember when I move to the left, so it looks like this, 6, 7, 3, and these come down as well. What I'm going to have to do is I'm going to have to multiply it by 10 twice. So times 10 times 10, right, is times 10 to the second power. So This right here replaces this. And now I bring down this times 10 to the second. Oh, multiply same base, add the exponents. So my final answer, it's got a lot of digits in it. Well, I suppose it could be way more. Times 10 to the 2 plus 2, or 4th power. There you go. Hope this helps.